Onan motor generator trouble diagnosis. The Onan motor generator consists of a 4-cycle, 2-cylinder engine which drives an AC generator. When problems arise, they usually occur in one of 3 basic areas: the generator, the control circuit, or the engine. We're going to discuss the most common problems in these areas and explain how to repair them. Usually, a specific symptom or malfunction indicates a problem in a specific area. Generator troubles usually show up plainly as no electrical output, or sometimes as inability to pull the rated load. Engine troubles usually show up as reduced voltage output, and perhaps in flickering or oscillation of electrical components if the engine is surging or rolling. And control circuit troubles usually show up in failure of the engine to crank or to start and run. Let's look first at the problem of no output, normally caused by a malfunction in the generator. It's important to isolate the no output problem to the generator, since its source could also be in the motor home wiring. To make sure the generator is at fault, see if power gets to the breaker terminal on the generator side. So, pull out the motor generator drawer as far as it'll go. Turn off the generator circuit breaker. Start the motor generator. Then check with a 110-volt test light or an AC voltmeter, with one lead connected to ground and the other to the breaker terminal. If there is power at this spot, the trouble is an open or short circuit in the wiring somewhere. To determine which, close the breaker. If the voltmeter reading then goes to 0, there is a short in the motorhome's wiring. If the reading remains the same, there is an open. The first thing you do to locate the problem is make sure the breaker isn't faulty. So with the breaker on and generator off, check across the breaker with an ohmmeter or self-powered test light. If there is continuity at the breaker, then to locate the open or short, trace back through the circuit in question and to the circuit breakers in the electrical compartment inside the motorhome. If, when you test the generator side of the circuit breaker with the breaker open, there is no power, you will know that the trouble is in the generator, and the generator needs to be tested. You can troubleshoot the generator with it in the vehicle. The only thing you have to do is remove the plastic end bell screens. We have removed the generator, however, so that you can see better what is being done. The first thing you should do at the generator is check the brushes. Obviously, you'd replace a broken brush or one that's worn beyond the limits. When you replace a brush, don't forget that they should be replaced in sets. Check that the wires to the brushes are intact, properly connected to their terminals, and that the insulation is not worn through to cause grounding. Clean the armature slip rings with a dry, lint-free cloth if necessary, or fine 240 grit sandpaper if there's any roughness. Use a very light touch. Be sure to remove all grit if you use sandpaper. Don't, however, attempt to restore their original bright finish, and don't use coarse sandpaper or any kind of emery cloth for the cleaning job. When you install the brushes, make sure the side-stamped bearing end is toward the bell housing. Also, make sure the springs move freely after you tighten the block screws. You should next check the bridge rectifier. Remove this screw to separate the rectifier from the housing and disconnect the wiring connector. Before you remove it, observe how it's installed. The writing on the rectifier can be seen through the cutout on the box. If you reinstall it any other way, it won't work. The rectifier is basically 4 diodes which are connected to provide a DC voltage to excite the field. An open diode would cause a loss or reduction of field voltage. To test the rectifier, check each of the 4 diodes with an ohmmeter in both directions. There's a chart in the manual that indicates polarity and what the resistance should be. For instance, the A to B resistance should be 8 ohms, with the black lead at A and red lead at B. With the leads switched to reverse polarity, the resistance should be infinity, since a diode conducts electricity in only one direction. If the test of any one of the 4 diodes doesn't meet specifications, the rectifier assembly must be replaced. Now, disconnect the field leads from the rectifier in the housing. Be sure to mark the leads and terminals for identification. If they're crossed at assembly, the generator won't work. Test the field for grounded or open windings. Use the same ohmmeter or powered test light. Check from each lead to the field case for grounding. There should be infinite resistance, no continuity, or the field must be replaced. To test for open windings, check the resistance between the 2 leads. On the 4,000-watt generator, it should be about 29 ohms. On the 6,000-watt generator, about 38 ohms. If you get an open circuit or high resistance, check the terminal ends on the wires for tightness. They can be repaired easily. But if a winding is open, you must replace the field. If you install a new field, here's an important point to know. The generator is self-exciting and depends on some residual magnetism in the field to build up voltage. So a new field must be excited or magnetized. To excite the field, connect it to a 12-volt battery momentarily and be sure you get the polarity right. Connector F1 goes to positive and F2 to negative. It is necessary to lift the brushes to check the armature. So, pull back on the leads to move the brushes away from the slip rings and use alligator clips on the leads to hold them back against spring force. Then, test the armature assembly for grounded or open windings with an ohmmeter or self-powered test light. To test for grounded windings, put one test lead on the end of the armature shaft and the other against each collector ring in turn. There should be infinite resistance, an open circuit in each case. If the test shows 0 resistance, the winding or ring is grounded to the shaft. Therefore, you must replace the armature. To test for open windings, check for continuity between the 2 collector rings. If there is no continuity, a winding is open. There's one other part of the generator for us to consider as the reason for no output, and that's the compounding reactor. Its function is to increase voltage to the field when the generator is under load, so that the generator can maintain its voltage output. If your shop has a variac, you can test the compounding reactor as described in the maintenance manual. However, if you don't have a variac, you should first check out all the other generator components. Then, if they're okay, but you still have no output, you can conclude that the compounding reactor is defective and needs replacing. In addition, repeated failure of the bridge rectifier is the result of an open in the thyrector in the reactor, in which case you should also replace the reactor. After you've corrected the cause of the no output problem and are putting the generator back together, be sure to get all the wires in the right places. Otherwise, the field won't build up. And don't forget to cage the brushes so they aren't damaged by the slip rings while you're installing the end bell. Then, be sure to test run the generator before you put it back in the vehicle. Put the fuel inlet into a gas can, connect a 12-volt battery, and start it up. Use a voltmeter or test light to check for output at the main circuit breaker. If the generator is okay and the engine is at the right speed, the meter will read about 125 volts. However, anything over 100 volts but less than 125 usually indicates that the generator is good, but the engine driving it needs service. We'll get to low-output engine problems in a minute. Before we do, what if you're not getting output with the generator back together? First, check to see if the field is okay. So stop the motor, lift the plastic flap, and disconnect the field leads. and hook them directly to a 12-volt battery. Remember, F1 to the positive post and F2 to the negative post. Start the motor again. And test for output at the circuit breaker. There should be about 50 volts with the field excited directly. If there is, it means you've got a wire or the rectifier hooked up wrong. If there's still no output, disconnect all the external wires to the brushes and reactor, but leave the field connected to a battery. Then check for output across two brushes on the same holder. Again, you should get about 50 volts. If you get a voltage at the brushes and had none at the breaker with the field excited directly, the reactor is shorted internally and should be replaced. If there's still no output, retest the field and the rectifier. Let's summarize. Most problems in the generator will probably be caused by the rectifier or the compounding reactor. But while you've got the generator apart, check it out fully. Test the armature for grounded and open windings with an ohmmeter or a powered test light. Also, test the field windings for an open circuit or grounding to the housing, and be sure the wire terminals are tight. Check the bridge rectifier by testing each of the 4 diodes for low resistance one way and infinite resistance the other way. Check the brushes for excessive wear, and be sure their wires are in good shape. Always replace brushes in sets. Clean the slip rings with a dry, lint-free cloth and remove any roughness by light sanding. Replace the compounding reactor if the other generator parts check okay, or test it first if you have a variac tester in your shop. And be sure to crank the unit up and test it for output before you put it back into the vehicle. And that's the story on troubleshooting the generator part of the unit. Now let's consider the problem of reduced generator output due to the engine rather than the generator. The engine must run smoothly, no hunting, roll, or surging, and at a specified RPM to produce the proper voltage and frequency output. Otherwise, there'll be disturbance in the electrical system. To check the engine RPM, plug the combined voltage frequency meter into an outlet inside the motorhome. With the generator running at no load, the meter should read a steady 63 hertz or cycles per second on the frequency meter and 125 volts. Both readings go up and down with engine RPM. If they're not correct or not steady, the engine should be adjusted. To adjust the engine, first set the throttle stop screw and the no-load speed setting with 0 load on the generator. Leave the master breaker on so you can read the meter. Turn off the roof air conditioning and the hot water heater, and unplug the power converter and any other electrical appliances. Pull the governor arm rod all the way back so the throttle stop screw is against the throttle shaft lever, and hold the rod back. Set the stop screw for 90 volts at idle with the governor not regulating the speed. Set the no-load speed at the governor spring adjusting nut. Loosen it to decrease speed or tighten it to increase speed. Adjust the nut for 63 hertz on the frequency meter. The maximum no-load speed is 1890 RPM, and the maximum no-load voltage is 126 volts. However, the frequency setting will be most accurate for proper generator output and is preferred to RPM or volts. Then, with the no-load speed set, check the engine for rolling or hunting or an unsteady meter reading. If there is a roll, adjust it out by turning the idle mixture screw on top of the carburetor in or out until the engine runs smoothly. Then check the frequency for proper no-load RPM after setting the idle mixture screw. Now, after making the engine adjustments, check the full load output of the motor generator. To do this, turn on the roof air conditioning and hot water heater. Plug in the power converter and load it up by turning on lights and appliances. The full load output reduces slightly from no load. The minimum values are 1770 RPM, 110 volts, and 59 hertz. Again, the frequency reading is preferable for accuracy. Adjust the main jet for maximum power. If there is any roll or hunting at full load, it can usually be corrected by adjusting the main power needle at the bottom of the carburetor. However, do not open it more than 1/2 turn beyond the maximum power point. The final engine adjustment is the governor sensitivity adjustments. This changes the spread in RPM between no load and full load operation, and also may take out any roll that the power adjustment didn't correct. Factory settings, however, seldom require adjustment. To make the adjustment, move the spring toward the pivot shaft for more sensitivity to reduce roll, or away from the shaft for less sensitivity. After a sensitivity adjustment, it's also important to recheck the no-load and full-load output settings again. Be sure to also check the governor-to-throttle linkage rod adjustment if the governor does not respond to load changes. With the engine stopped and tension on the governor spring, the stop on the carburetor throttle lever should just touch the stop screw. If an adjustment is needed, just lengthen or shorten the rod at the ball joint. Let's summarize. Low output and hunting can normally be corrected by a simple adjustment of the carburetor and governor, following the order we described. With no load, set the throttle stop screw for an ungoverned output of 90 volts. Then set the no-load output at the governor spring adjusting nut for 63 hertz on the frequency meter. If the frequency is right, the voltage and RPM will be right. Remove any no-load roll by adjusting the main jet. Check the full load output, which will be slightly reduced from no load, following maintenance manual specifications for minimum frequency or voltage. Remove full load roll at the main power adjustment screw. If it's necessary to make a sensitivity adjustment to narrow the no-load to full load spread or to take out roll, move the spring at the governor arm. Then check the linkage rod adjustment and, if necessary, correct it by lengthening or shortening the ball joint. Finally, recheck the governed no-load and full-load speeds. That's what to do to correct a low output problem. Now let's consider a generator that's unable to pull a load. A big drop in output under load can indicate that the engine needs a tune-up or that the compounding reactor is bad. If there's an obvious drop in RPM under load, start your diagnosis by checking the engine tune-up items. So first, be sure the no-load output is to specifications. Remove the air cleaner element and inspect it for restriction from dirt buildup. A restricted air cleaner is a major reason for a loss of power under load. Tap the air cleaner base lightly on a flat surface to clean it. However, you should install a new element if it doesn't become clean or it has over 200 hours of service. Next, remove the float bowl from the carburetor and inspect the float and the needle valve. Be sure the float is free and that the valve is not worn or clogged. If the float should stick in the up position, the valve will stay closed and the engine will suck the bowl dry. You should also check the ignition system, especially the points and timing. To set the timing accurately, use an ohmmeter or continuity tester. Connect it between ground and the lead from the breaker box to the coil. Disconnect the lead from the coil. Insert a socket wrench in the hole at the front of the flywheel to turn the engine by hand, and watch the ohmmeter to see when the points open and close. To see the timing marks on 4,000-watt engines, remove the dot button at the top of the scroll. On the 6,000-watt engine, the timing hole is at the rear face of the scroll. On some early motor generator models, the timing mark is at 21 degrees before top dead center. The mark is at 25 degrees on later models. Nevertheless, on all models, set the timing as close to 25 degrees as you can with the engine cold. On earlier models, you'll have to guess a little at 4 degrees left of the 21-degree mark. Turn the crankshaft counterclockwise until the points close. 0 resistance on the ohmmeter. Then turn it in normal rotation until the points just open as the needle moves upscale to infinity. The timing marker should then be at 25 degrees. If an adjustment is necessary, use a small hand mirror behind the breaker box to see what you're doing. Use a short-handled screwdriver and ignition wrench to adjust the points so the timing is right. Here are a couple of tips on timing. 1. A feeler gauge adjustment of the points isn't always accurate enough. That's why you should use the ohmmeter to measure the exact point when they break. Also, if you can't get dead on to 25 degrees before top dead center, it's better to go 26 degrees than 24. A retarded spark makes the engine run too hot. Now, if the engine is tuned properly, it should be able to pull a load without a big drop in output. So if engine RPM doesn't drop much, but voltage output does, there's a good possibility that the compounding reactor is bad. To test the reactor, lift the plastic flap and connect a DC voltmeter to the field leads. Clip the positive lead to the F1 wire terminal and the negative lead to F2. Then read the field voltage under no load and full load conditions. With the generator operating at no load, the field should be receiving about 40 volts. At full load operation, the compounding reactor should step up the field voltage to about 100 volts to maintain generator output. If it doesn't, the compounding reactor is defective and you should replace it. Remember then, when the generator fails to pull a load, try to determine if the engine RPM is dropping, indicating the need for tune-up, or if the RPM holds fairly steady, indicating a reactor problem. To tune the engine, check the no-load output first. Then service the air cleaner element and check the carburetor float valve and float. Check the ignition system and set the timing to 25 degrees before top dead center. To test the compounding reactor, measure the field voltage in load and no-load conditions. If a load doesn't boost reactor output to the field, the reactor must be replaced. Let's look at one more thing. Diagnosis of the motor generator control circuit. The main function of the control circuit is to start and stop the engine, so naturally, it can be the source of starting problems. The best way to diagnose control circuit problems is to follow the control system troubleshooting guide in the Onan manual. Let's take an example to show how to use it. Assume the problem is that the engine cranks and kicks but doesn't start. Look at Chart B. The first check asks if the F1 fuse on the control board is okay. So locate fuse F1 and check both of its terminals for power. If the fuse is okay, check the K1 start solenoid for 12 volts while the engine is cranking. If 12 volts are present while the engine is cranking, see if the engine starts with the start switch pushed. So, connect the jumper between terminals 9 and 11 and operate the starter. The engine does start. Therefore, you can conclude that the relay contacts are defective and you should replace the printed circuit board. However, on older units, you might find the problem is simply dust in the non-sealed relays. So first, before you remove the circuit in older units, pull the caps on both relays and scrape the points with a knife blade. We've discussed here the most common motor generator problems that you'll encounter. If you have any questions relating to what we discussed or to other motor generator problems, consult your GMC Motorhome Service Manual and the Onan Service Manual.